All right. Okay, guys, so today we're gonna focus on section 3.6. Talk about what a one-to-one function is and what an inverse function is. We're gonna visit those topics. But let's do a little warm-up. Remember, I am collecting this one, so put warm-up. Today is the eighth, and then make sure you put your first name and please at least put your last initial. Okay, so I'm gonna give you a table. We're gonna put names here, name, and then we're gonna do age here. 1, 2, and let's put some names. I have Jim, Carlos, Lisa, Sumar, and then I have Tex. All names of students I've had in the past. This is their ages. These are their ages here. 20, 19, and 23. Okay. So it's a table with names and ages. And I have two questions that I would like you to discuss with your classmates. One is, does this table represent a function? We're going to review that definition that we did. And if so, what are the domain and range? And if it's not a function, just say it's not a function. Number 2. Does anybody need a sheet of paper? Is Alexa here? Alexa, let's see. Okay. Okay. Think about it. I'm gonna have you write down some notes or your responses so I can kind of get an idea. We covered the definition of a function, I think, on the second day of class. Okay. I'm going to revisit that definition. How can I tell if something is a function? For this one, I'm not correcting it. Oh, you mean your sheet? Yeah, it's whatever you want. But the biggest size is in the sheet. And that's the warm up here, okay? For the second question, if you do say it's a function and you're going to write the domain and range, make sure you do the correct notation on how you're going to write the domain and range. All right, I think it's the usual. U4 here, U4 here, U4 here to check in. I'll have you check in. So you two here to check on. Just check in with your next to you. All right, guys, do it. Right here.
One element.
Like saying. And that's like. Yeah, that's not. I think it's like.
Couple more minutes, or about 1 more minute. Be careful with your notation. Are you writing your domain and range? If you said it's a function. Careful. All right, guys, let's see. So, what do we think? Is it a function? So if it is a function, what is it that you're considering to be the input? Name. Okay, so we're saying these are going to be the inputs. But can't spell input. Inputs, and then you're outputting is age. So if it's a function, what must happen?
One input equals one output.
For each input, you get exactly
One output.
one output. Is that true?
Yes.
Each name corresponds to only
One.
one age, right? Now, is it okay that the 19 shows up twice?
Yeah.
Yes, that's okay. Because Sumar only corresponds to age 19, only one of them. And Jim only outputs the age 19, which is fine. So you can consider this, if this is a function. Yes. You could say, well, if I input Jim, the output will be 19. Right? And so if it wasn't a function, then this Jim might correspond to two different ages, and that's where it gets weird. So yes, it is a function for that reason. So then if it is a function, you're saying these are the inputs and then these are the outputs. So therefore, the domain is going to correspond to what? The names. The input, exactly. So if this is a domain. Is the domain, the things that you're inputting, are they numbers or not numbers? They're not numbers. So I was walking around and I did see people use numbers for the domain. It's not numbers because it's just named, right? Now, what did we say when we have a list? The bracket notation, yeah. Yeah, squiggly one. And so all you do is you just write the list of inputs. So I would write all the names, Jim, Carlos, Lisa, Tamar, and then text. And then for the range, I did hear some of you guys. So here, is it an interval or also squiggly set bracket? How did you know it's not an interval?
Because this is all. It's not to.
Yeah, you don't want to say from 19 to 23 like this. Otherwise, if you do that, you're including 19.1, 19.2, and all these other decimal units, which are not part of the table, right? So that's why that's incorrect. But you would need to do a set. Now, would I write the 19 twice?
No.
You do not have to know. Okay, or when you're writing it as a list, you just literally write it one time, as long as it shows up. Now, I know I did say last time that you could do something like this. But you gotta be very careful with that dot, dot, dot. Because this means, by looking at this, it means you can include 19, 20, 21, 22, 23. Right? But is 21 part of an, is it an output on this table?
No.
No, so you want to be very careful with that. Okay? So in this case, I don't want that number to be there. I think 21, right? So then I would have to list 20, 22, and 23. And those are the elements of the Cool. Okay, good. Good little review on that. We're going to use some of those concepts today. I'll leave this here. Please pass up your warm-up. Good job. Oh, the date. Oh, yeah, I did write the date. Okay, the date. I was like, I really need that date. So I know where to assign it there. Good job. Thank you. Thank you. Oh, it's like warm in this class. Jesus. All right, guys, so. Yeah. Whoa, hold on. Do I have the right section? I made a typo in my notes here. Okay, section 3.6. We're going to start with one-to-one functions. And so we're going to start with a question here. I'm going to refer to this table, okay? For the function given by the table from the warm-up. Can we create a, let's say, reverse function that assigns to each, if I'm going reverse, what do you guys think I'm going to be doing? Yeah, so it's like there's the inputs and outputs swap. So what would I say after that? So that reverse function assigns to each. What are we inputting in this reverse pretend function here? Yeah, so to each age, that assigns to each age one unique what? Name. So that's my question. So if I wanted to use this table and go the other way and make the age the input and make the name the output, can I have such a function?
Yes.
Roman,
Yeah.
you can? What are you thinking?
One version 19.
Well, here, okay, good. I'm glad you pointed that out. So if I wanted to do that, right? If I wanted to do that. Let's say this inverse, we'll see how we figure out what this is. If I plug in 19 and I look at that table. Am I using this 19 or am I using this 19? Yeah, that's perfect. Yeah, but that's exactly where the issue comes up. So notice that on this table, if I try to go the other way, now the number 19 has two different names associated to it. And that is what makes it fail to be a function. Because the input 19 has more than one output. And I can't do that, that's fine. Okay. Question about what it says here? And so in this case, what is it, the answer? No. No. And then because this right here. Because 19 has more than one output, in this case, so it can't be a function. Okay. And so the table represents, from what we said in the warm-up, this direction is a function, right? This was okay. You guys were discussing with your classmates. But if I try to go the other way, then it fails. Okay. And the reason it's failing is because even though it's okay for the output 19 to show up here and here, when I try to go backwards, that's the reason why it failed. And so this table represents a function that is not what we call one-to-one. Sorry, can you guys read that in the back? Yeah, I'll just repeat it. So the table represents a function that is not one-to-one. So what the heck does that mean? What is that? What does it mean for it to be one-to-one? So let's define it. Let's define what that means. So we're going to say a one-to-one function. First is a function. Is a function where each output corresponds to exactly one input. So it sounds very similar to like the definition of a function, okay? And that's why I wanted to spend some time on it. But it's kind of like the backwards version of it. So a one-to-one function is a function, but it's a special function where each output corresponds to exactly one input. Okay, and so why does that table fail to be one-to-one?
It doesn't have exactly one input and one output. There's more than one output of input.
Yeah, you guys see, this is the list of list of outputs that you gave me, right? So is it true that each of these corresponds to exactly one input? No, 19 is the one that failed. It corresponds to multiple inputs. Yeah? So that's what makes it not one-to-one. Let's look at more examples. Let's look at more. I want to show you guys a whole bunch of different ones. Oh, actually, let's do this. Let's do examples here. And let's do non-examples. Let's do tables. Now let's just keep it just with numbers, X, Y. So 0 corresponds to 5, 1 corresponds to 7, 2 to 9, 3 to 11. So to see if it's 1-to-1, you guys need to do two things, not just one thing. One is you gotta first double check if it is a function. Okay, so you look at each input, you only get one output, right? But if I gave you something like this, would that be a function? No. Why is that? 0 has multiple outputs. So then immediately, because it's not a function, it's just not even you can't even consider it to be a 1-to. Okay. But in this case, yes. Question.
Horizontal line for that?
We're getting there. Yeah. So let's look at one that's not. I mean, there was one here that I gave you, but let's look at a different one. Let's say 0 corresponds to 5, 1 to 7, 2 to 5, and 3 to 9. Is it a function? Yes, each x corresponds to only one y. But why is it not a 1-to-1?
As well as two.
Yeah, you have this output 5 corresponding to more than one output, yeah. So output 5 corresponds to multiple inputs. Okay. And so that, by definition, is why it fails to be 1-to-1. Okay, so those are tables. Look at a graph now. Oh, you can kind of think of it like this, like a visual. You got 0 and 2, and they both are outputting 5. So therefore, 5 corresponds to that. More like a visual person there. Okay, now let's look at a graphical example. See the graphs. Let's look at the graph of the function x cubed versus the graph of the function x squared. You guys have the handout that we did on Monday for the parent functions? Actually, who needs a handout? Look at the back. So with your finger, give me a gist of the graph. What does this look like? X cubed, not x squared. That one's the S shape. Right, that one's the S shape, so that one's gonna look like this. That's the structure of the shape of the graph of that parent function. Versus this quadratic is parabola, your good old parabola, facing up. That. Okay, so now the question is it a function? How did we check real fast to see if it was a function? Vertical line test. So passes the vertical line test? Yes. Passes the vertical line test? Yes, only crosses it once, right? So both of these are functions, but now we got to check the other condition, which is, does each output correspond to exactly one input? So output here, we're thinking y. Input here, we're thinking x. So another way of saying that is, does each y output correspond to exactly one x? Question mark.
So since they both has the vertical test in order to be a 1-to-1 function, it needs to pass the vertical line test and the horizontal line test.
The horizontal line test, which I'll mention in a little bit, but yes, correct. Yeah. So is it true that on this graph, if you look at a point on the graph, right? Does each y value of this graph correspond to only one x value? Yes. Versus here, let's say I pick a random y value. That corresponds to this point here on the parabola. And this point here on the parabola. So let's say, let me just call that x2, and let's call this one x1. So what we have here is we have a y coordinate that corresponds to two different x values. So two different input values. So this tells you that when you plug in x1 or x2, they both give you the value y, which is kind of like what we were doing here. Is that okay? So because of that, is it one-to-one? It is not one-to-one because of it. It is a function, it's just that you're having a y value correspond to multiple inputs. And so as Rohan and Bobby were mentioning, there's this thing called a horizontal line test, where in this case, let me do a different color. Oh gosh, let's see this sucker work. Hold on, let me do this. Puts the ink out. Okay. There you go. So if we were to cross this with a vertical line, I'm sorry, horizontal line, exactly at that y value, it crossed it twice, here and here. Versus if I use a horizontal line here, no matter where I cross it, it's only going to cross it once. Okay. And so now we're going to have a different test called the horizontal line test to see if it's a one-to-one function. So if a horizontal line crosses the curve of a function, so notice it has to be a function, more than once, then it is or is not. If it crosses it more than once, it is not one-to-one. No. Now, you gotta be careful. If I give you this graph on the test, and I say, is this a one-to-one function? Your explanation can't just be no, because it tells the horizontal line. It's just a way to check it. You would have to add the part of the definition, which is no, because there's a y coordinate or an output value that corresponds to more than one input using the definition. Okay, let me have you guys real quick, little concept check here. I'm gonna give you 3 graphs. So which are functions? And then which are one-to-one functions? Quick little concept check. All right, we got this bad boy here. We have nice little squiggly. And then we have this guy. So with your group, just do a quick little concept check. Which ones are functions? Which ones are one-to-one functions? Oh, the camera.
Don't use the
It's a little warm, guys. I'm sorry. I'll try to radiate some energy onto you.
freezing outside.
I know. Okay, let's see. Function,
Yes.
let's do this, function. Yes, you guys said yes? Correct, yes. Every X value only corresponds to one Y value, so check. Is it 1 to 1? Yes, it is 1 to 1. All right, function. Say it again? Yes, every X value only corresponds to 1. Is it 1 to 1? No, it's not. Notice that if I draw this horizontal line, it's crossing it multiple times here. 1, 2, 3. Hell no. Hell no. Okay, so no, it's not. Function.
No.
Function?
No.
No. Fails a vertical line test. There's an X value that corresponds to 2 different Y values. So no. So if it's not a function, can it even be a 1 to 1? No. Automatically, no. Good. And that's it for 1 to 1. It's not too crazy, but I did want to spend some time to distinguish that. That's going to be important later on when we start introducing logs and stuff. Okay? So I'm warming you up for all that later on. What I really want to spend time with is inverse functions. That one I want to spend some time. Let me have you guys take a 5-minute breather. Okay, relax, go to the bathroom, some water. It's like really, really warm. You'll probably get another 10-minute one, yeah. So take a little 5-minute breather. We'll start again at 1:20.
Yeah. I didn't say. No, you're all right. That's why I wanted to be very.
No, it's just hot. Okay. Oh, I keep breaking. I made so many typos in my notes. Sorry, hold on. There we go. I'm fixing them now. Okay, guys. So inverse functions. Inverse function. Okay, so now that we have an understanding of what a 1-to-1 function is, what we're gonna do now is assume everything we're dealing with now is a 1-to-1 function. Okay? So if a function is 1-to-1, then it has a what I'm calling a reverse function called its inverse function. But it has a fancy formal definition. So let's go off of that. So for a 1-to-1 function, f where, let's say you plug in some input A and it spit out some output B. Its inverse function, and the way we're going to denote, like the name of it, is we're going to write f with a little -1 on top of it. Okay. So its inverse function is the only function where, in this case, into this new inverse function, you'll plug in B and it'll spit out A. And this will be true for every input that gives you the output B. So whenever that happens, the inverse function will always do the reverse of it, or the inverse of it. But if it's a little abstract, so let's get a little visual. Let's say this is the domain of S. This is where all the A's live. Okay, all the inputs. They'll live here. Let's say I pick a random A. And then I plug it into F. And it gives me B. So I plugged it into F. And it gave me B. So B lives where?
Outside of that.
What's that called? Where it lives? What's that? The range. The range, right? So let's just make that a different shape there. So this lives in the realm of the range. Range of F. Okay. Here are the inputs of F. Here are the outputs of F. Now let's look at the definition. It says the inverse is the only function that now inputs the output of F. These B's are the outputs of F, and these are the ones you're going to be plugging into the inverse. So now, where do the inputs of the inverse live? In the range of F. So the things you plug into F are now going to be things that F output. And so when you plug those suckers in there, and then it should spit it out and correspond it exactly back to where it came from. Okay? Like that. That looks like a weird P. So this next part is conceptually important, okay? So what's the domain of F inverse? The range of F. Because that's where the inputs of the inverse function are. So the range of F, that set, is really equal to the domain of F inverse. Okay? And what about the range of the inverse?
The range of.
Yeah, it's equal to the set that's the domain of F. So you're going to see a whole bunch of different problems that we're going to work on that use this concept here. Okay, so make sure that picture is nice and big in your notes, because it'll help you. You ready? Let me erase this. Can I have an example of a function and its inverse, like as a graph? Totally, I'm giving you all kinds of examples. Graphs, algebraic expressions, tables, points, all that good stuff. Okay, so let's look at some algebraic examples right now to play with. So here's x cubed. And let's just compute some values here. If you input the number 2 into the x cubed function, what's the output? Plug in the 2 here, you cube it. What's 2 times 2 times 3?
8.
8. Okay. Let's do another one. Plug in -3. -3 cubed. -3 times -3 and another negative. So it's going to be negative. Okay. So this is the function. The inverse function, I'm going to give it to you right now, and then later on we're going to figure out how to find it. Okay. So what operation does this do to an input value? It cubes it. So what do you think is the opposite of cubing? Cube rooting, and that's exactly gonna be the inverse. It cube roots it. Okay? To do the reverse, you just cube root something. But let's just verify that this actually the inverse, because this property has to happen. Right? So in this case, if I plug in the number 8, let's just ignore this for now. You plug in the 8 here. What's the cube root of 8? 2. And notice that it's kind of doing the reverse of this. So it is true that if you swap the inputs and outputs, you get that result. So here, if I plug in -27, I better get -3. And is that true? If I cube root -27? Is it okay to cube root a negative?
Yes.
It is okay to cube root a negative, but not to square root a negative. Okay. So here's just some examples to kind of show you algebraically and numerically that this is happening. Okay. I did want to mention some important remarks. Let's see, what can I do? So, important remarks. So the first one is, since, I'm gonna go off of the definition here. Since f of A spits out B, and when I plug in B into the inverse, it spits out A, that is going to imply that you see this A right here? That A is this A. Cool? Okay, so what can I replace this A with? What is A equal to? It's equal to this stuff. F inverse of B, right? So I can replace this A and substitute it with this to make it look like a composition. See that? But this has to equal what? B. See that tricky algebra there? Stare at it for a little bit. Okay. F of A, if F, since F of A equals B, and then we do a reverse with the inverse function, but A is the output of F inverse of B, and this is supposed to equal B. So notice that that's saying that, like this, if I cube root an X, but then I cube it, the operations will undo themselves, and then I'll end up back with X. Question?
So it's like when you're dividing, the thing, you kind of cancel them out.
They kind of do cancel out each other, yes, but it's not, you're not like dividing, but yeah,
Yeah, but-
similar canceling out
Yeah.
thing is happening, yes, correct. So F and its inverse, always when you compose them together, they give you the same result back. What if I was to swap the order of composition? Let's see.
The same thing happens?
Crap, hold on.
Distinguishing
This is B, right?
Yeah.
But B is equal to F of A. So I'm going to replace this B with F of A. But according to this, what is it supposed to equal? A. So notice that again, when I compose F inverse and F with anything, some value A, it'll just spit out A. They cancel each other off. Correct. And so you can check that with these here. Plug in X cubed, plug in the cube root into the F function. And the cube root undo each other. Or plug in the X cubed here. If I plug in the X cubed here, the cube root and the cube undo each other to just give me the answer. And so this is a very useful property of inverse functions. They're the only ones that do that. But they undo themselves when you compose them. The other thing is a common notation mistake that students make. So F inverse does not equal 1/F. Okay, versus like a number. A number. Like if I was to do 3 to the -1, that is 1/3. So here, where I don't like it, but the notation for reciprocal is this -1. For numbers, for numerical, like when you're doing it, applying it to a number. But when you use this -1 for a function, it does not mean reciprocal. It means, careful, it means inverse function. Okay, so like in this example, right, like in this guy, notice that the inverse function of x cubed, if f of x is x cubed, the inverse function does not equal 1/x cubed. It's not, it doesn't equal the reciprocal. It's not that easy. Okay? So be careful. Okay, so now what I want to show you is if I just give you the function, how do you algebraically find its inverse? Let's see how we're going to do that. And then I'm going to have you guys try some because I've been talking way too long. All right. And this thing is so weird. So let's call this steps for finding inverse functions.
Is this an example or like more?
This is some steps with an example, and then I'm going to leave that there and I'll have you guys try. Now, different textbooks do it in different ways. Okay. I'm going to do it the way I have my solutions have it. That way you're not getting confused with the way it looks. Okay, so let's do, I'm going to write 3 steps. And then next to those 3 steps, let's do an example. So the example, if you want, maybe on your notes, do the example on the bottom of this. Let me write what the question will look like first. It'll say find f inverse of the function 3/x plus 1. A random function that we're just picking. That was a little more complicated. Okay. So what you're going to want to do is you're going to want to set the function equal to y, meaning you're going to want to write it like this. That's probably a throwback for some of you. What the heck do I mean by that? Is, see that here's a function. I'm going to set the function equal to y. So therefore, I'm going to rewrite f of x like this. 3/x plus 1. To set it equal to y. Because the function gives you the output value y. Okay, the next part is where some textbooks could differentiate. Also, if you covered this in a past class, it might be a little different, okay? But the point is that whatever you input into f becomes the output for the inverse. Cool? And whatever you output for f becomes the input for the inverse. So the x's and the y's swap. Because now they swap when you're considering the inverse function. So in the next part, you're going to interchange all x's with y's. Anything that's an x, you're going to rewrite it as a y. Anything that's a y, you're going to rewrite it as an x. And that's because of the inverse property that inputs become outputs and outputs become inputs. So I set my function equal to y. Now I want to start creating the inverse. All the y's become x's, and all the x's become y's. That's what ends up happening for inverse function. So now to find the actual inverse function, you're gonna use algebra, where the fun part is, to isolate y. Okay? To isolate y. That means I need to get y by itself. Okay, let's see, let's help me out here with the algebra. You want to subtract one first? Okay, so let's subtract one to both sides. So the ones will cancel on the right side. What happens on the left side?
-1.
Correct. They can't combine, so you just write it as x minus 1 equals 3 over y.
What about it like the-
Multiply by what?
and the-
Here's the fun, here's the. Well, we're trying to get the y isolated, right? Right now it's a denominator. So that's what's making it tricky. How, think of this, how can you cancel fractions off? Yeah, multiply both sides by y, right? But here, when you multiply by y, what do you gotta be careful with? Well, I guess you gotta be careful with the y, not only multiplying the x. It needs to multiply the whole thing, so I need to manually put parentheses on that. Okay? Okay, now the y's cancel. So I'm left with y times x minus 1 over 3. Okay. When you get to this step, here's where it gets a little nasty. Sometimes you do want to distribute that y in there. And sometimes you do not want to distribute. Okay. What's the ultimate goal? What are we trying to do? Trying to get y by itself. Okay. So do I want to bring in the y here? Yeah, I can, if I divide by x minus 1 on both sides, that will isolate the y. Okay, versus if I distribute it, I'm gonna get yx minus y, and that's gonna make it a little bit more complicated. So you wanna be, at this point, just be careful. Do I distribute or do I just divide off to give me the ultimate goal that I want? In this case, I don't want to distribute because I can just divide both sides by x minus 1. And then when I do that, I got y is equal to 3 over x minus y. So is y isolated? Correct. So what is that answer right there?
The inverse.
It's the inverse function. Yeah. So then therefore, f inverse of x is this result that you got. 3 over x minus 1. That's your answer. Oh, it looks like those Mario things. It's like torpedo things. But what's it called? Bullet bills? Yeah. Cool. Should do that for my other class. Yes, right here. Well, it's not that it would be incorrect. You wouldn't be incorrect. Let's just do that real quick. Let's see. So, hold on. There it is. We were. Oh no. Where were we? We were x. Oh yeah, x minus 1 equals 3 over 4. So you're saying you wanted to cancel off the 3, multiplying it by. Okay, you multiply it by 1/3. Is that how you would have written it? Okay, so then the 3's would have canceled. But what would you be left with here? 1 over y, not just y. Like that. Mhm. It kind of isolated the y, but you want y, not 1 over. Yeah. Yeah, so actually, How else can I rewrite this so that it's one fraction? Yeah, notice that I can think of this as x minus 1 over 1, right? And then multiply numerator with numerator, denominator with denominator. And it just becomes this times 1 over 1 times 3. I can write it like that as well. Right? If I have two fractions that are equal to each other, I can flip it and I'll still get equality. So there would be 3 over x minus 1. Is that the same answer? Yep.
By seeing, there's an equal sign between them, right?
If there's an equal sign between them.
Yeah.
Yeah. So if I have A over B equal to C over D, then I can flip these and I would get B over A is also equal to D over C. Equal, though, there's an equal sign.
Yeah.
Yeah, be careful. And we get the same answer. So it's not that it would have been wrong, it's just there would have been more work. Fine. Question and then question, yeah.
So if we did it in the non-traditional way,
You did not get penalized for it. You just used some examples, I guess. Someone had a question on that. No? Okay. All right, let me leave this and then let me give you guys some two practice problems. Okay. So. Practice. Find F inverse. Number 1. F of x equals 5 minus 2 over x. Be careful with the algebra on that one. Number 2. F of x equals the cube root of 4x minus 10. Let me practice those. With your classmates, check with each other.
Swap X and Y. If you do it a different way, fine.
I'm not sure where to start. My suggestion. Careful with that negative, okay? Okay, I see some people moving to problem 2. Can I just have you do a quick check with your classmates? See if you're on the right track for number 1. Do a quick check. I'll go around if you guys have questions.
Yeah.
First, I wasn't like you guys pulled up, it's not, it's why it's like, why it's what she, that. It's 64 and this is why. So that's why. Okay, subtract the 5, I think we get that one.
Yeah.
Wow, what's that? All right. You graduated already?
Well, I mean, it's just like a one day.
Yeah, I got it.
Like a why, I was like, I thought it was. Total trivial during the exam, it's not actually your calculations, it's just like you're writing. Now I feel that. Better distributed.
Which one?
Or not distributed.
You plus third over 4.
Let me see what you mean.
It's cubed over 4 plus 5. You're racing. Oh, yeah, of course.
Oh, yeah, that's fine.
Yeah.
I know. What's up?
You don't know when you multiply by side and
Here?
you put x minus 1 in parentheses.
Correct.
If it's like another number like 4, but you also put.
Like instead of a Y, if it was
Yeah.
4, correct.
Yeah.
Yeah, yeah. Wait, G, let me see what you got.
I don't know how to start the section.
Let's see. So let's start by setting it equal to Y.
Is this changed?
Not yet, not yet. So now you rewrite all the Y's. So this Y. Okay. Now careful with this 3. You're slowly put down more and more. You want to make it a small cube. Okay. So now to you know when you have a square, actually let's take your point. Which one's it? What would you do if you had that? How would you undo this problem?
You're not sure. So to undo a square root, you square. Because so you get this. If you square both sides, the square roots and the square undo each other. So. Oops. So. The cube root. Will the cube root again? So your cube rooting. To undo a cube root, cube. You raise it to the third power.
Okay.
So you put parentheses to the third power.
Yeah, that's true.
So put a parenthesis here, so you're cubing the whole thing. But if you cube one side of the equation, you have to cube the other side. Mhm. So now this cube and the cube root cancel each other out. Completely. Yeah. So now on the right hand side, you're gonna be just left with what's inside. Nope, because that's part of the cube root, like all that gets canceled out. But now, this side, you can just rewrite this as x to the power of third. Yeah.
Oh,
Because the cube. You don't have to calculate by 1/4 on both sides. Perfect. So now, you just gotta get y like that.
Yeah.
Let me have you try. Do that. Okay.
Yeah, the one before, right? Yeah.
Okay, guys, let's take a little mini break. Come back at 2:10. Back at 2:10.
oh,
I'll stay if you guys have questions.
Why have this in yourself?
we lost track of time.
Oh.
I was like,
It's like me at meetings. I don't always.
would I switch that before?
Probably for a very. The other.
So I just subtract, I did my. Yeah.
On this side, you have to do it on this side of the equation.
So this would not sit like that. So then this would just become 10 to the power 3.
No,
That's
what?
x to the power 3.
So technically more like formally,
Uh-huh.
what's happening is you have. Right? So what you're more formally doing,
Yeah.
you're adding a 10. We can just put writing it below, but
Yeah.
you're adding a 10 here, and you're adding a 10 here.
Oh, so it would be 10 to the power 3 plus. With x to the power 3.
Exactly.
Equals-
Yeah, sorry.
Okay,
Just like this one, you see how here we subtracted the 1,
yeah,
so you can't really combine them.
Yeah.
So we just rewrote it as x minus.
okay.
This is all the algebra that you're gonna see on the homework, okay? The examples you guys just did. So now we're gonna focus on the graphical part. So let's see how that's gonna play. Graphical. Representation. Inverses. Okay. So here, you're gonna help me complete this statement here. If I tell you that the point A comma B is on the graph of F, what are you inputting into F? If this point lies on the graph. You input A and it outputs B, right? That's what it means for it to be in the graph. Okay. So if this point is on the graph of B, then which point will have to be on the graph of the inverse? BA, perfect, good, because the input become the outputs and the outputs become the inputs. So B comma A must be on the graph of its inverse, of the inverse. That's a super helpful key for your home, okay? let's see how this is gonna play. So given the graph of F, sketch the graph of its inverse function. So I think just. And let's say I give you a graph, it's given to you. Let's go up to 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. Oh wait, because I know that usually takes a while. So much more. Okay, so now I want you guys to sketch the graph of F, okay? Again, on the homework, it'll already be given to you, but put a point at 0, -3. Then put a point at 3, comma 2, comma -2. And then at 4, 0. And then just, this is the graph of F. This is little piece right there. That's why we're signing it for sure. And actually, it won't even show you the coordinates of the points. It will just give it to you like that. Okay? So what you need to do, you don't even know what F equals as an algebraic expression. All you know is a graph. And they're asking you to sketch its inverse. Okay? So what you're going to want to do is use this fact. You're going to find some points that lie on the graph of F. Let's do the obvious bolded ones. And let's write the coordinates. So this is the point 0, -3. This, what are the coordinates again? 3, x, yeah, x is 3, -2, and then this one is 4, 0. So if these points lie on the graph of F, then you swap them opposites, and then they have to be on the graph of its inverse. It has to be because of the definitions of inverse. So if I swap this, green. If I swap it, that would be -3, 0. That'll be this point. And then if I swap -2, 3, that'll be this point up here. And then last one is 0, 4, which is going to be up here. This point connected to 3, -2. So then this point will connect to -2. So even though I don't know the inverse function, like I don't know the algebraic expression, this property has to be true. So therefore the graph will have to look like this. Question.
Sure. I was just saying that, I mean, it makes sense to me. It's a along the life is that.
Yeah, so that's another, another property of all this stuff. Is the graph of F and the inverse, they're going to be symmetric because of this whole swapping of coordinates. So the x's become the y's and the y's become the x's. Where are points where x and y are the same? That's one of them. Where else? When 1, 2, 2, 3, 3. So they're along this diagonal. See that? So this diagonal, oh man, hold on, let me do my rock star. Let's see. Oh, damn it, didn't work. Sorry. What about the red one? Let's see. Oh, okay. So this diagonal here. Yes. So the graphs of F and its inverse are symmetrical to the line y equals x, where x and y literally equal themselves. Okay, yeah,
So is it like when we're doing the reflections, except across both the X and the Y axis?
yeah, yeah. For reflections, it was across the y-axis or x-axis. Here it's across this diagonal line y. Okay. Let's keep going. Another kind of type of question that they'll ask you on level sign, they'll say something like this. They'll say, no, hold on. I'm moving on from this. So notice that the point 3, -2 is on the graph of F. And what that means is if you input what, you output what? If you input 3, you output -2. Okay? So here's a Weber sign question that you're going to get. They'll give you the graph of F. Right now you don't know this, okay? They'll just give you the graph of F. So pretend the green part's not there. And they'll say compute F inverse of -2. They'll just show you the graph of F. And they're going to say compute that guy, F of -2, without knowing the graph. Okay. So you want to use the fact that the x's and the y swap. So you're going to look at the graph of F and you're going to say, okay, here I'm using -2 as an input, but for F, -2 is really the output. What coordinate does that correspond to on the graph? What point?
That's it.
Wait, do you mean like X or Y or something?
So yeah, so here's the thinking behind this. This is the input for F inverse, right? So then you're going to ask yourself, well, for F, it needs to be the output. So what is this right here?
3, okay.
Yeah, you kind of got to think a little backwards. See that? Gotta think a little backwards. You're going to say, okay, on the graph, where does the graph output -2? It outputs it here when I input 3. So because you input 3 into F to give you -2, what should this equal? 3. Because they swap.
Okay.
Why do we know, how do we know if it's Y or X again, in terms of?
Because what this is saying is essentially what the definition says. This should be true. These two have to always agree with each other. Whatever you plug it in, whatever you plug into F and output into B, it's the reverse for the
Okay,
inverse.
and it's gonna be 3 regardless of which one it is.
Yes, yeah, be careful. Okay, I'm gonna give you one, okay? Yeah, let's try it. You guys could do it. It's one of those things that it's either gonna be like, boom, I get it right away, or it's like, God, I'm still like, it's really bugging. So just be patient with yourself.
Anything more after the graphs?
No, that's it. I mean, there's a worksheet that I have that I want you guys to do.
More content?
No, yeah.
Is this gonna be other thing?
Yes,
This is like the last thing we're
this is the last thing that will be on the test.
Oh, okay.
Okay, No. Mm-mm.
Inverse functions or when you're.
Inverse functions.
Oh, okay.
It's part of the study guide. Okay, guys, so here you go. Given the function of f whose graph is shown, determine f inverse of -4. Okay. Try to conclude that with your group. Given the graph of f, determine f inverse of -4. You think you got it? Just don't worry it out. Just check in with the group. And try to explain to each other why.
I guess so nervous once professors start grading stuff. So then my grade is going up. Or it's going
To read.
next week is the worst because I have other questions. So my grade is on my grade state. First stage, grade, fourth stage. You drop. Literally, because I have 100% for all the classes, so like. Once exams go in, it's like. This one is all about studying. Oh, well. What's that is? I have Bible, so you provide, but I don't even know Sunday, sorry. Organic. I love
Okay, guys, let's see. -4 is the input for the inverse, right? That's what it shows right there. So for f, it needs to be the, not the input, the output for f. So if it's the output for f, what coordinate does that correspond to in the graph? X or Y? Y. Let me write it right here. Let's work from my auditory learners. Let's see. So we have that we're being asked to find this, right? Okay. But if we swap it for f, -4 needs to be the output. So I need to see what this question mark is the thing I'm inputting. So how do you use the graph? -4 has to be the output, so it has to be the y coordinate on the graph. So here is y equals -4. Where is there a point on the graph of f that uses this -4 as y? Right here at 3, -4. So at 3, -4. That tells you that what must be plugged into f? 3. Therefore, this outputs 3, and that's the answer. Okay? Okay. So I have a handout that I want you guys to practice, covering everything we did. Oh, no. Perfect, right? There's only 4 questions. The answers are in the back. The solutions will also be posted. Try these out. You do not cover it. Syllabus and on time. Or you guys say,
I think I will better because it's you know, I know the guy look. Yeah, I'm I'm gonna get like you.
I'll go get it. You do that, make the solutions.
I got one for my and my friend got like my since in one. Yeah. I'm sure there's having.
So solutions have been posted. And then the answer keys at the very back.
You still want to answer that? Not everything. Just like last time when we went outside, they wanna do something similar.
Three, and then like, I took that down. Like, how it goes.
Well, first there's three rows, so Y,
Equals X.
like X equals Y equals, and then just get Y. Correct. We're not entirely exact, but like the number, put up there, put up the consistency. Right. Yeah. And out there, like, we're reading,
Guys, be careful with number two's algebra.
And then I added it to the. I'm not really
Oh, my bad. I didn't know.
Yeah. It's like you're like minus. Two, minus two.
I was.
Where do you at? No, it's- It's your mind. You look into my heart and then-
Yeah.
Two lines in the- You don't do that. You don't need to put it by the bottom of the top. Why put
Okay,
my the X.
I don't know if that's it.
You good? You're in, go ahead, start, yeah.
So then when I do I y plus one,
Right?
y plus one,
Not on top and bottom, because in this case, you want to cancel fraction
so it would be y plus one,
just by one of them,
both sides.
to both sides, correct?
Y plus one,
Okay, by doing that, what happens to the right side now?
it cancels out
Perfect,
with this one,
perfect, yep.
so it would just be. What about that? So y plus one times x.
Mm-hmm.
Oh,
You want to in this case, because the X is being multiplied with both of these, so you put a parenthesis between them, yeah.
Now.
Perfect. Perfect.
And then.
Mhm.
That's given the one.
You do, but this was trickier because there's a Y here and there's a Y here.
Yeah.
So unfortunately for this example, this is one of those where you do have to distribute the X in here. Mhm. For not multiple, you have to do right here.
Y plus one.
Ah, that sounds.
Because the bird's the only sign. Yeah, third year. That is would be move something over. We're over here. Oh, yeah, I got multiply x minus five. Oh, sorry, I'm multiply by it. And then it's done that. And the book is already there. Multiply x is possible. I don't know. Or the X.
Yeah, I was thinking about it. It's like, that's really why. I think one of the people were the.
Okay, guys, we should go to. Is there gonna be one like that on the test? Maybe.
All right.
Okay, guys, so for number two,
Big tears. We're allowed four cigarettes on the test. You might want to spit them out.
Yeah, okay.
it's recording.
How many plans? Did I-
So let's take a look here. Number two is bugging you guys. Okay, so far, everybody has the first two steps pretty good. So you're setting it equal to y. Then you're replacing all the x's and y's and swapping them or interchanging them. So this becomes an x, and these two x's become y's. Okay. From here, if you see a fraction with the algebra, it's helpful to get rid of fractions. So last time we got rid of fractions by the multiplying both sides by y, right?
Yeah.
But here the denominator is y plus 1. So I think everybody's good there as well. Most people that I'm walking around are seeing that step. Okay. I'm seeing that as well. But what is x being multiplied with? Just the 1? And so I'm gonna put a parenthesis there to demonstrate. Now this cancels. And so I'm left with y plus 1 times x equals 2y minus 3. So I have it perfect. I left it on there on purpose. Okay. So see, there's a difference between what we had here. This canceled off. And we just had a 3. So there's a difference between what we have here and what you have there. Okay. Remember that you gotta remember what your ultimate goal is. Ultimate goal is to get rid of y. or sorry, to isolate y. Here, the y is by itself, all out alone, right, chilling, they kicked them out. And so we were able to just divide the x minus one, because then that would give me the y by itself. Versus here, the thing outside is not the thing I'm trying to isolate. It's inside here. So I don't want to divide by y plus one, because I just go back to where I started. So remember I was saying sometimes you have to distribute, sometimes you do not. Here's an example where I have to distribute. Okay, so I have to. Sorry. You gotta distribute. So then you're left with yx plus x equals 2y minus 3. That's already one kind of challenging thing. The other challenging thing is what to do from here. Like, what do I move around to help me with this problem? Negative x. Many things you could do, but here's the ultimate goal. You're trying to isolate y. So what you're gonna want to do is everything, if you're doing a problem like this and you see different terms with y's in them, put all the things with y's on one side and everything that does not have a y, move it to the other side. So I can either move this to y to join it with this one, or I can subtract the yx so that it joins the 2y. Either way you do it, doesn't matter. You'll get the same, you'll get an equivalent answer. So pick one. What do you guys want to do? Do we want to move the 2y this way or the yx? Okay, let's say I do the yx. So I have to subtract it to both sides. It'll cancel. That. Now, do I have all y's on the right? No, this -3 is not part of the club. So we gotta get it out of there. How do I do that? Add it to both sides. So then we end up with x plus 3 is equal to 2y minus yx. Okay. Why is that helpful? Because now everything here has a y. So what can I do? You could factor it out, because now they all have a y there. So I'm going to factor out a y from here. So I factor it out, I'm left with 2 minus x, and then x plus 3. And look, now I got the y by itself. Or sorry, I'm almost there. Now I just have one y. Kind of like this scenario here. But that could only happen if I rearrange the equation so that everything on one side has a y. That's the only way that can happen. So now what do? Divide by the 2 minus x. Perfect. This cancels. And then now I have my y equaling my inverse function. On the back of the page, though, it doesn't give you that, huh? No. Okay, so let me explain to you. You would get full credit here, and WebAssign would also give you full credit. Okay. It does, yeah. It can trace what's equivalent. So on the back, I don't know why I wrote it. It's annoying. But you could stop here. You'd be done here. Okay, this is the answer. But so it matches the back. Let me see. So double check. You see how instead of 2 minus x, it has x minus 2 on the back? So what's happening is this. It's if I want to rearrange this and move the x to the right or to the left and this to the right, how would I do that down here? You kind of can, but you just have to carry the sign with it.
Multiplication, order doesn't matter in multiplication, but it does in addition and subtraction.
It won't matter with addition,
But subtraction.
but subtraction it will. Yeah. So you can't just do that. You can't just do that. But yeah, you can think of 2 plus negative x. So think of this as 2 plus negative x. And then now I can swap it so that it becomes negative x plus 2. That you could do. Okay. But that does not look like, the answer key does not look like this. And I don't know why they went all ham on this, but they factored out a negative from there. So then they did this. They factored out a negative from the bottom, which leaves me with, yeah, now that becomes a -2. I know, it's so stupid. I don't know why they did that, but here's another thing to know about fractions. If I have a over negative b, that'll be equal to the fraction negative a over b, which is also equal to negative a over b. All these three are equal to each other, okay? So that means if I have a negative on the bottom, I can also move it to the top. Okay? So I have a negative here. So instead, I can move it to the top. So I can write it like this. You won't have to do this, okay? It's just, I know you guys are probably like, why is that equal? Then what do you do with the negative? You distribute it inside, and now it'll look like the back of the page. So all this is equal, but you won't have to do that, yeah.
So I got this in, as the twenty,
Okay.
because when I, but in, on the other side, when you're asking if you wanted to do X, Y.
That's right, as well.
So I did two. Yeah, it has two Y's the other side.
You move, yeah, exactly, so,
then-
perfect, yeah, perfect, yeah, if you would have instead moved this here, then the result would have looked like that. Yes,
Monday, is what we're doing like in the chapter after that test?
for Monday, we're gonna go over, yeah, whatever we cover on Monday will be on exam 2, correct. Okay. I'm gonna end class early today, okay?
Yeah.
With Nintendo Direct. I'm just kidding. Let's get her done. It's over already? Oh, yes. Okay. I want to see what's there. So we'll end it now. I'll stay though. I'll stay if you guys have questions.